In this video, I'm going to go over the procedure to create geometry and mesh in Icem for the cooler. But as I mentioned in our tutorial session last Friday, the geometry I created here, in fact, is a really simplified version of the cooler. It is not really close to the real geometry. So here I am going to draw a cutaway of the geometry I'm going to create. So here we have this insulation layer. Okay, so this is the insulation. That is the form. So basically this is a cube shape or box shape geometry, and I assume the size is 1. It can be 1 meter or 1 foot. Here this size is 0.6. Okay, and those numbers are not necessarily real practical dimensions. I just use I simply pick up such random numbers in this tutorial. Then there is the inner container. Okay. Hey, what's going on here? Okay, this container, its size is 0.4 on each side. So here we have this air gap. Okay, so okay, yeah, it should be red. So here is the air gap. Here is the insulation, that is form, and this region obviously is the inner container, container, which basically will be filled with water. Okay, and water is used to simulate the tissue. Okay, you can see that the origin of these three, box-shaped geometries cannot coincide. Okay, for example, here for this largest box, its origin is here. So suppose this is my x coordinate, this is my y coordinate. Here, of course, is 0, 0, and the origin of the second box excuse me, should be 0.2, 0.2. Okay, and here this origin should be 0.3, 0.3. here is 0.2 because I really want this distance equals this distance, right? Since here the side length is 1, here is 0.6, so I know that these two distances coming together should be 0.4, so each one of them should be 0.2. Okay, so that's why here the x coordinate of this origin is 0.2. You can find the coordinates of this origin with the same principle. Okay, then we start Icem. Icem. Okay, I will first create those 3 boxes according to our sketch here. Okay, so I use this create modify surface, then standard shapes, and the first one is box. So x, y, z size are all ones. Origin is 0, 0, 0. Apply. So that gives me the largest box. Then the middle box, 0.6, 0.6, 0.6. The origin is at 0.2, 0.2, and 0.2. Okay, so the middle one, then the inner box, say 0.4, 0.4, 0.4. Okay, so when you simulate real cooler, okay, and most likely you will have more layers of boxes, but you just follow the same procedure. Okay, so all 3 boxes were created. At this step, you can see here in this small window we have this tree type of structure here, right? It's called display tree. Basically it determines which entities are displayed, which are not displayed in this window. So you can see the geometries like curves, points, surfaces, and parts. So one entity, for example, a surface, in fact can be shown, can be put in both geometry and parts. Okay. Parts are used to include those entities, some entities together, and give them one name so that you can use them for some convenience. For example, you can include all the surfaces of one box in one part, so that in the future you can apply the same boundary condition to all those surfaces. Okay, so basically, yeah, you just group some geometrical or blocking entities in parts so that you can conveniently apply boundary conditions to those entities, or apply material types to those entities. So here we will create more parts to include those surfaces. Okay, let me, okay, to do that, right click parts and create part. Okay, so let me first create a part called okay, face outer surface, right, outer box. Here, in fact, in our real simulation, you will want to, differentiate the top surface, the bottom surface, and all the 4 side surfaces as 3 different parts. Okay, because according to heat transfer, the natural convection at the top surface is different from the lateral convection along the vertical side surfaces, which is also different from the lateral convection at the bottom surface. So you want to differentiate these 3 types of surfaces, but here for simplicity I will lump all those outer surfaces in one part. Okay, so this is a part name, which is more or less arbitrary. It's up to you. Then I will select the entities which I want to be included in this part. So I click this arrow, then I select this surface, this top surface, this side surface, bottom surface, and I also want to include this front surface and the back surface. In order to see those surfaces more clearly, you can press F9K on the keyboard to switch to the dynamic mode. Okay, you can see hit F9 to return to selection mode. So right now we are in the dynamic mode, which means we are in the mode that we can change the orientation and location of our geometries. Okay, this angle seems fine, right? It really facilitates our selection of these 2 surfaces. Right now we can see these 2 surfaces pretty well. So I hit F9 button to go back to the selection mode. You can see now I can select. So I select this surface and this one. Okay, that's pretty much what I want to include in this part. So I press the middle button, which is, well, in most of our mouses, this middle button in fact is a wheel. So I press this middle wheel. Okay, in fact all the 6 surfaces now are included in this newly created part whose name is face outer. Okay, I press the middle button again. Okay, but now this time is at a blank area on the screen. To double check that your part is correctly created, you can uncheck the display, this box before this part name, so that you disable the display of this part. You can see definitely is correct, because all those 6 surfaces now are not displayed. Okay, you can turn the display back on. Okay, then we create the second part, which is the part that includes the 6 surfaces of the second box. Okay, I will call it face Well, in fact, this is the interface between the outer box and the air gap, right? Air gap. Okay, notice that air gap is here. Okay, is in between the second and the third boxes. So those 6 surfaces, in fact, is the interface between the outer foam and the air gap. Okay, and then we select these 6 surfaces. Okay, it's pretty difficult to select the last 2 surfaces. So again, I use F9. I rotate the geometry. Then I select this. Oh, no, not this guy. Okay, if you incorrectly select an entity, like here, I selected this edge, which I should not. Then you can cancel your selection by using the right button, which means cancel. So cancel it. Then select the right surface. Then this surface. Nope. Okay, cancel it. F9. I rotate it. This surface. Okay. Then press the middle button. Okay, to confirm your selection or finalize your selection. You can see this part is created, and a unique color theme, or how should I say that, is used for this part. So different parts, in fact, have different colors. Okay, what I mean is that different parts are displayed with different colors. Okay, here again, I can press the middle button at any blank area on the screen. Then I can disable the display of the second part so that it will be easier for me to select the surfaces of the inner box. Okay, so the very last part I'm going to create right now is the face of the inner box. I just call it face inner. Then this surface, this surface, this surface, this surface, this surface, and this guy. Okay, the middle, click. That's it. Okay, face inner, you can see its color is green. So if yeah, it's correct, right? It is correct. Okay, so now I have all the surfaces grouped in different parts, so that in the future when I import this mesh into Fluent, well, export this mesh into Fluent, basically I can very conveniently apply different boundary conditions to each part, okay, each group of surfaces. Okay, then the next step is to create so-called blocks. Such blocks are used to create structured mesh. So if you want to create a structure mesh, you always have to create such kind of blocks. Okay. You probably do not quite understand why we have to create blocks before we can create a mesh. In fact, the underlying logic is like this. Say here of course we have a very regular shape, right, or box or cubic type of geometry, but it's possible that in more complicated situations you may have complicated geometries. Okay, suppose something like that. Okay, to create a mesh for such a complex geometry, what Icem does is using a certain mapping technique. So it first create a block, okay, for example, which is always a very regular shape, like a rectangle shape. Then it associate, different. It will associate the real geometry features, like for example here we have 4 boundary curves, okay, on the real geometry, and we have 4, say, A, B, C, and D. We have 4 edges over this very regular, block. So I tell Icem that I want to associate this curve 1 to edge A, curve 2 to edge B, curve 3 to edge C, and curve 4 to edge D. Then Icem knows how to create a mesh on this real geometry, and its method is like this. It first create a mesh on this very simple block shape, okay, which is really easy to do. Okay, I believe that if you take a few hours, you can write a program to do that. Okay, then with such a mesh, right, you know the coordinates of those mesh points, like the coordinates of this point, this point, this point, and so on. Then it uses a pretty simple, well, not that simple, but relatively simple algorithm to project each point, okay, onto the real geometry, because it knows, okay, where it should be projected. For example, this point, okay, this guy here, since it's located on A, and this A is associated to curve 1, so with a certain algorithm, this point can be projected onto the curve 1. Okay, it probably is here. Okay, then this point is projected to here, suppose. Okay, this one is here, this one is here, and this one, of course, is here. Okay, just like this one should be here. Okay, and so on and so forth. So eventually you will have, something like that. Okay, a mesh like this. Yeah, something like that. Okay, of course, I'm not saying that the mesh quality is very good in such a situation, such a simple situation. That is why sometimes you will need a good, blocking strategy, so that you can eventually end up with a good mesh quality. But I believe that somehow you understood why we need a block and why we need to associate, those edges of blocks to curves of the geometries, right? Okay, so this is what we do here. We have such a 3D geometry, so to create a mesh, I first create a 3D block, and the part name cannot be solid because we do not really have solids only, right? We have foam, but we also have air gap, we have water, right, inside this inner container. So both air and water are not solids. So it's it's not good to name our part as solid. Probably simply call it cooler. Okay. It's a 3D bounding box. Okay, this is only, well, it's not the only 3D blocking option, but we have to use this one for our case. So apply. Okay, now in fact we have our block. In fact, once we create a block, those curves of geometry now become, quite colorful. They are displayed with many different colors. So those colorful lines, in fact, are our geometry curves. Okay, you can disable the display of those curves. You can see those colorful lines disappear, and now what you see, okay, this black box in fact is our initial block. Okay, then we will cut our block to create more blocks. Okay, so that eventually we can do our association. So I use split block, then this one, O-grid block, then select blocks, use this icon with a plus sign here. Okay, I only have a block. Okay, so here you can randomly pick. Okay, not really randomly. You just click this one single block. Okay, if you do not see it, it's here. You say, oh, I cannot see it. Then you can disable the curve, and then you see it. Right? It's the only block you have. Then middle click. Okay, so this block is selected. You can simply apply. That's it. Okay, you can turn the display of curves back on. Well, it's not very good because now this new inner block somehow coincide our inner container. So let's undo it. So do it again, but now this time change the offset to 0.6. Okay, turn on the curves. Now it's a little bit better. Okay, let's do the association. So click associate and click associate edge to curve. Associate edge to curve. Okay, edge are the edges of block. Okay, curve are the edges of geometry. So basically you always select edge first, then you select curve, the corresponding curve. So this edge, okay, before we do that, turn on this option here. Okay, project vertices. So click this edge, then middle click, then click this curve, then middle click. Okay, you can see that the edge automatically, slap. Is that correct word? Okay, slap onto the curve it associated to. This edge, this curve. Okay, every time you have to select, then middle click, then select the curve, then middle click, select, middle click, select, middle click. Okay, select, middle click, 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 select, middle click. Select, middle click, 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 select, middle click. Okay. To double check that all the edges are correctly associated, you can turn off the display of curves. Now you only see those edges of blocks. Basically, either okay, you can see those edges turn green, right? Which means they have been associated, which is something you really want to see, okay, or want to have. They have to be associated, although sometimes they are not associated correctly. Then you have to make changes, okay, which means you just reassociate edges to the correct curves. But anyways, at least you have to make sure that those edges are associated. Okay, they have already been associated to some curves, and they turn green. Okay, then we go ahead to create another layer of O-grade. But before we do that, in order to facilitate our selection of this block, I will turn on the index control of blocks. So right click blocking here, then click index control, and this index control appears here. Click this up arrow here, then immediately you can see that now you only have this one single block, okay, because in fact right now we have two layers of blocks, okay, this outer layer of blocks, in fact here we have 6 outer layer blocks, okay, then we have this inner layer block. So all those outer layer blocks in fact have an index of 0 along this dimension 3, which means this radial direction, and this inner block has an index of 1. So once you increase this index to 1, then only this inner block is displayed. Okay, then I use this O-grade and select this one, 0.6. Well, probably not very good, but maybe 0.2. I don't know. 0.4 maybe. Apply. Okay. Then turn on the curves. Do the association again. So associate. This edge to this curve, I believe. This edge to this curve. This edge to this curve. This edge, this curve. Okay, every time you select the edge first, then press the middle button, then click the curve, then select the middle button, and then repeat this procedure. Okay. Not very sure which one I have already done, which one I didn't. Okay, anyways, let me see. Yeah, it seems that all those edges turn green, so okay, good. But not enough. Okay, now we have blocks for the form, okay, which are those blocks with the index 0 along dimension number 3. We have blocks for the air gap, which are those blocks with index 1. We also have one single block with index 2. Well, you know what? This edge is not green, right? So that means I have to do association for this one. So click this one again, this edge to this curve. Okay, now it should be fine. Yeah, it's also green. Okay, notice that those edges do not need to be associated. Okay, those are interior edges. They do not correspond to any curves. Okay, here my practice is that I create one more layer of O grade. Okay, but I want to test something different. Okay, how about I do not create one more layer of O grade? I just use these 3 layers of O grade. See what happens. Okay. First, I will create more parts to those to group those blocks corresponding to different materials. Okay, see, I create part called zone foam, that is insulation, right? Okay, now remember that I'm going to group those parts, so they are not geometries. Here are the geometries, okay, but blocks. To facilitate my selection of the blocks corresponding to the insulation foam, those blocks, I use this index control, right? I decrease the maximum index too much. Okay, it seems fine. Or is it right? Okay, this one is 0. Anyways, okay. I will select this one, this one, this one, this one, this one, okay, this one, what else? I'm not sure if this one is okay. This one. Okay, let's see if I'm doing it right. So if I disable, okay, that's correct, right? See, all those blocks, 6 blocks disappear, and now they appear. Okay, so this one is correct. Then reset. Okay, now I have those blocks. I will include them in zone air gap. Okay, then, well, this one, this one, this one, this one, but I should have 6, so I switch to the dynamic mode and select this one, and okay, this one, and this one. No, not this one. This is the very inner. How should I? Okay, this one. Yeah. Middle click, then disable the display. Yeah, that's right. Now you only have this inner block. So this one will be called zone inner, which is water, essentially, right? Okay, I say this guy. Okay, so it's somehow different from the practice I showed you last time, but I believe both ways should work. So here is the block corresponding to the water zone. okay, the innermost. I also have the zone corresponding, I mean the blocks corresponding to the air gap. I have those blocks corresponding to the foam. Okay, basically that's it. Then we will really create the mesh. First go to the mesh tab, then click this global mesh setup, select a maximum mesh cell size. Let's try 0.03 and click check display and check apply. See how big is this maximum element size is. Okay, it is this big. Well, you know what, this is only a tutorial, right? It's just some practice. So in the real simulation, you will want to do a mesh size study, which means, for example, here you first use this 0.03 mesh size and do your simulation, and you get your results. Then you have your mesh size. Okay, use a size of, for example, 0.015, and redo the mesh and redo the simulation and find the results, and then compare these two sets of results and see how much difference they have. Okay, if they have a significant difference, that means your mesh most likely is not fine enough, right? It changes a lot when you change your mesh. But if they only differ a little bit, then that means your mesh probably is fine enough. Okay, so then we go to blocking, then we click here, this icon, pre-mesh parameters, then click apply. Then Icem is going to do some calculations and show you that with your mesh size, then eventually your mesh will have how many nodes, that is the mesh points, okay, how many of those such points, and how many cells. Okay, here we only have hex cells, so the number of hex cells is about 160,000, which is not that many, so it should be okay. Okay, so if you are satisfied with such numbers, then you check the box before pre-mesh under blocking. Then a pre-mesh will be created. You may think I do not see anything. That's because we disabled the display of faces. Okay, now you can see the mesh. Okay, if you are satisfied with this mesh, you may ask, okay, how do I know if this is a good mesh or not? You can check the mesh quality. Okay, just click pre-mesh quality, histograms, then apply. You can see the quality is really high. Okay, the highest possible quality is 1, the lowest is 0. Fluent is not going to accept any mesh whose quality is less than 0.2, and we usually require that the mesh quality at least is higher than like 0.6, 0.7, right? It's just like the passing score or grade of any course typically is like 65%, I guess. Yeah, so this is also true for the mesh quality. Right now the minimum quality is about like 0.85. That is pretty high. Okay, so it's good enough. So let's first save our project. Okay, you just save it anywhere you want. Okay, like for me, I will save it on my desktop. Okay, So project saved, then right click pre-mesh, right click, then choose convert to unstructured mesh. Okay, once this step is finished, your mesh is official. Okay, so now you can see this box before pre-mesh in fact is unchecked, but you still see this mesh, okay, because now you really have a real mesh. You can see this mesh folder, whatever, now show up on this display tray. Okay, so what you see now in fact is a real mesh. Okay, so this is your real mesh. Okay, the last step is to rewrite your mesh file into the file format that is recognizable to your CFD solver. Okay, this is done by using this output mesh tab. You first select the solver you are going to use, and the default is Fluent, obviously, right? Because this is the product of ANSYS company, okay, the company that produces Fluent. So the very first option is Fluent, but in fact it has the ability to accommodate to many different popular solvers. Yeah. Okay, apply, then write input. It asks you save current project first. Well, you can select no, okay, because you have just saved the project, but you can always save. Click yes. Then open, and make sure that you select 3D because it's a 3D mesh, and you can use whatever file name that is, you know, appropriate for you. Here I simply use Fluent. Done. Okay, done with translation. So now I have such a mesh file called fluent.msh on the folder where I saved my project, and for me that is my desktop. So it is here. You see? Yeah, it's here. Then I'm going to, read this mesh file into Fluent. So I first open the Fluent. Okay, make sure you select the 3D version of Fluent. You should use double precision solver, which is more accurate, but of course it also uses more computer resources, like more memory, more CPU. And again comes with a cost, I guess. Okay, then start. Okay, be patient. Okay, great. Then go to File, Read, Mesh. Then change this, file extension. This is the latest mesh file extension, which looks pretty weird. So you probably want to use .msh. So it's pretty weird that ANSYS updated this mesh file extension, but they didn't do that for Icem. I mean, in ICM they still use .msh, so and no one cared. Okay, so I will find my msh file, which is on my desktop. Okay, desktop. Where's my file? Okay, that's mysterious. Probably on OneDrive, then desktop. Okay, yeah, here it is. Okay. Okay, it takes some time to read the mesh file into Fluent, and if you see this done here, okay, without any warning message, error message, then it's a good sign that your mesh file is correct. But to be sure with that, you can first, click check. Okay, again, you do not see any, mistakes or error message here, so which means your mesh is fine. You can display your mesh, okay, which is nothing but a box. Yeah. Okay. Sometimes you want to scale your mesh. Okay, the reason is because in ICM, right? Sometimes we use a different unit from the unit used here, or understood here, or interpreted here in Fluent. In Fluent, it always use like meters. So if, for example, you think or you believe that you use foot in ICM, okay, so this box length is 1 foot, but in Fluent it will simply interpret it as 1 meter. That is of course not what you want. So in such a case, you can do the scaling here. See, this mesh was created in like foot, right? If you do that, then you click scale, then it will be automatically changed to the correct dimensions. Okay, so Fluent knows that, okay, this side in fact is not 1 meters long, it is 1 foot long, which converts to SI units, should be something like 0.3 meters, yeah, something like that. Okay. You at this step you should be able to see many different zones, because we have 3 zones, right? The zone for the foam, the insulation, the zone for air gap, the zone for water. You also should see many different boundaries here, because we define all those faces, parts, right, for the very outer surface, for the interface between the outer foam and air gap. You may find that Fluent automatically produce a so-called shadow for any interfaces. Okay, for example, this face of outer and air gap, that is an interface, right, which is this face. Okay, those are red faces. They are interfaces, which means they are faces of 2 different zones, right? Each red surface, okay, like this one, is both a surface of the foam and a surface of air gap. So for this reason, it created 2 parts. Okay, it duplicate the part. Okay, so that you may be able to apply different conditions to the same face, because essentially they are, I mean, it is two faces in a certain sense, right? It's a face of foam, and it is a face of the air gap. So this is a logic behind such kind of duplications. Okay, I will talk about how to do the simulation in my next tutorial video. So I will stop here.